Hi, my name is Kantil.
I'm Grahit.
I'm Dhruvi.
And I'm Vishnu, and this is iasoAI, Referral Form Generator. So Iaso is the Greek goddess of recovering from illness, so we thought it would be an apt name given the nature of our project. So iasoAI is an automated system that generates patient referral forms. It's a Class 2 multi-agent LLM system that takes in patient conversations and clinical notes and outputs a partially filled out referral form that can then guide patients to the specialized care that they need. So right now, this is done basically by primary care physicians manually, and it's very time consuming and it's also very error prone. So we're trying to automate this process and streamline it to make everybody's lives easier. So with regards to our data set and processing, basically, as you know, patient conversations are confidential. So what we're hoping to do is to generate our data using GPT-4, and in our case, we generated 100 different test points. These are both clinical notes and patient conversations. And as you may also know, referral forms vary wildly across practices. So for our purposes, we've specifically chosen one from the Markham Stouffville Hospital, which you'll be seeing on the next slide. With regards to the components of our data set, basically into our system, into our whole system, is going to be entering patient-doctor transcripts and clinical notes that come from a patient visit, for instance, and out of the whole system comes a partially filled out PDF form. And throughout the whole pipeline, we're transmitting information using JSON. So this is our initial system structure, and like I described, that first part is generating the actual data, so we're using GPT-4 for that. And then once we have that input data of clinical notes and patient conversations, we then give them to 3 separate extractor LLMs that try to extract the key information that's needed to fill out the PDF. And those 3 LLMs generate 3 JSON files. Those 3 JSON files are then given to one validator LLM that takes those 3 in and then gives us one validated, hopefully correct, JSON output, which is then converted to PDF using our last PDF conversion module. With regards to our implementation, as I said earlier, we generated our data using GPT-4. So to make sure that these conversations are realistic and true to a clinical setting, we verified them by running them by clinical professionals that were close to the team. And we also tried to use a higher temperature value when generating our data to encourage variability in the types of conversations that are produced. On the other hand, for the extractor and validator, we use much lower temperature values to encourage consistency and also to make our outputs way more deterministic. Finally, with regards to the validation and PDF sections of our pipeline, we manually validated their outputs to make sure they were actually doing what they were supposed to be doing.
Moving on to evaluation. Our evaluation depends on which type of field is being evaluated. So we have single select fields, which is basically just a text box. It can be on or off. We have multi-select fields, which is like a set of related fields. So they can be, a few of them could be on or off. And there's free text field, which is basically just a string. If it's a single select field, we only measure the accuracy. If it's multi-select, we measure precision, recall, and accuracy. And if it's a free text field, we do the evaluation on our own. And the main reason is for this is because we figured that Blue Score didn't work that well. So here are some of the original results that we got. As you can see across the board for precision, recall, accuracy, we have pretty solid metrics, high 90s and 100s. However, notably, the single select fields are a bit lagging in their accuracy. So looking at these results, we decided to update our system structure to something more simpler based on the feedback that we got from the proposal. And we decided to condense all the 4 LLMs into just one single LLM that's doing the extraction, and we just got rid of the validation process entirely and just took its output and made them into PDFs. So the results of that was this. So there's slightly lower performance across the board. So we see more 90s coming in. And notably, the biggest drop that we saw was that one of the multi-select fields, its precision dropped dramatically. So this latest model, its outputs are presented over here. So like it's pretty straightforward. Whichever fields were selected in the JSON get checkboxed in, and if there is anything to write, it gets filled up in the form. So, if we want to see what these results mean, some of the things that we took from it were that we hypothesized that the lower performance on the single select fields was because that to fill those in, the model has to do a little bit of inference, because oftentimes the doctor doesn't directly say that, oh, I'm going to refer you to this clinic. They say, I'm going to refer you to this area in general, and you have these conditions. So it means that generally that thing should be filled out. And then the other thing we noticed is that even though we used a much simpler system other than the 4 LLMs, we got a very similar performance, although one field's performance was less. So given the business settings, it might actually be beneficial to use the more simpler system. The things that we learned were mainly that to start off with a simpler architecture to begin with. So the idea is that like it's easier to build on it rather than to condense a more complex system. To adjust the prompts, because we figured that the prompt engineering actually gave us a bigger boost in performance than any sort of adjusting the agentic system, so having multiple agents interact with each other. And the last thing we learned is that to agree on handoff protocols between different scripts. So the data generation, the extraction, and the evaluation scripts, each one of them has to have a very set standard in which they are giving their outputs and inputs, so that it's easier for many people to work together and basically have all their work come together at the end. That's it.